Greetings, my name is Caroline Yepes and I am a master's student at the University of Puerto Rico. This is my thesis work measuring manufacturers' responsiveness and suppliers' observed order variability due to flexibility in a two-echelon supply chain. As we know, flexibility is a strategic capability that allows supply chains to adapt to market needs. However, adding flexibility could also add unwanted variabilities and increase cost. Therefore, to determine if a flexibility process is viable in a company, we need to identify and quantify its flexibility effects on the supply chain. This model aims to answer this question by determining how flexibility impacts manufacturers' responsiveness and suppliers' variability. The problem addressed involves a two-echelon supply chain with a manufacturer and a supplier. The manufacturer carries two products and only produces one at a time. They need to choose between two production lines of different technologies that allow fixed or variable production volumes. This decision will impact the supplier. The supplier does not have the capacity to adapt production and does not have the access to the final customer. Therefore, they need to plan their inventory according to the manufacturer's observed demand. System dynamics was chosen because of the ability to deal with highly complex systems like this case. One of the challenges of this problem is the discrepancy in the conceptual framework of flexibility and the lack of an approach that can address the complexity among the multiple dimensions that the concept involves. For this project, flexibility is the ability to adapt to internal and/or external influences, but there are multiple ways to achieve flexibility. We decide to model manufacturing flexibility through lot size variation, product flexibility, material handling flexibility, and machine flexibility. The variations on these attributes define the production line to be modeled, which can be highly flexible or non-flexible. In a highly flexible line, for example, the production time decreases and the lot size and the production rate increase. This increases the finished product inventory and decreases the manufacturer's lost sales and backlogs. Also, in this flexible environment, when the manufacturer's lost sales increase, they speed up their machines, increasing flexibility level and closing the loop named lot size flexibility. The manufacturer production rate also affects the raw material requirement and the supplier shipments, affecting the supplier's variability. Also, the raw material inventory affects the decision to manufacture product 1 or product 2. Moreover, demand is considered as a driver of flexibility, and the manufacturer's ability to detect, react, and preempt change by forecasting demands affect the lot size. The higher the demand, the higher the lot size of product 1 or product 2. As seen, this is a complex problem. For example, there are 8 loops in which flexibility level is involved, including between 5 and 9 variables. This holistic combination of relationships between flexibility, lot size, responsiveness, and variability is an innovative approach possible by using system dynamics. For this moment, the stock and flow diagram is still in process. This is part of how it looks until this moment. The logic behind the flexibility level is highlighted. Machine, material handling, and product flexibility decrease the production time and increase the production rate. Also, when the lost sales rate achieves a maximum, the production time is adjusted. This is in the flexible scenario. In a non-flexible scenario, flexibility level is 0 and the production time remains constant. Thank you very much. I would like to know if you have any questions or recommendations. My email is available in the conference site. Thank you.